Okay, in this video we are going to learn about horizontal circular motion on a level surface. And welcome to Education with Eleanor. If you like this video, press the thumbs up and also subscribe. Okay, so we have a car of 1300 kilograms. So I'll represent it using a rectangular box, and it travels around a bend with a radius of 13.0 meters. So if the center is here, I'm just representing it with a C because I can. You don't have to if you don't want to. But we know that the radius is 13.0 meters. And this car is going around a bend. There is a total sideways friction force of 15,500 newtons. So from the center, it's going towards the center there. So the friction force here is 15,500 newtons. Okay. And the road is not banked. That's how we know that it is level. We want to calculate the maximum constant speed at which the car can be driven around the bend without skidding off the road. So what's really important to understand here, and let's actually clean this up a bit because it's a bit messy the way I've drawn it. I'm not a fan. So that's better. So we have a radius here of the 13.0 meters, and we've got that friction here from the middle of the center of mass, and that's F friction is 15,500 newtons towards the center of the circle. Now what's happening is our net force when it's circular motion or centripetal motion is given by mv squared on r. Now if a car is turning around a bend and it's going at the maximum speed or less than the maximum speed, then the friction force here is the only component that's causing the force to go towards the center of the circle and causing the car to actually turn into the center of the circle. So therefore we have our net friction force, our net centripetal force being the friction force. So F net is equal to the F of friction, the force of friction, is equal to mv squared on r. And we are solving for v squared. Alright, now I'm going to rearrange this and put mv squared on r on the left hand side, and it's equal to our friction force, and that's equal to our net force, just so we remember. Now our mass is 1,300 kilograms. The v squared is what we're solving for, and our radius in the denominator is 13.0 meters. And this all equals 15,500 newtons. And I'll scroll down so we have some more room. So let's keep solving. V squared will now be 15,500 newtons multiplied by 13.0 meters divided by 1,300 kilograms. So our V squared will equal 155. Now let's have a look at these units. Our units are newtons, meters divided by kilograms. The equivalent units to newtons are kilograms, meters per second, and then we'll fill in the rest. So there's meters, and then there's the kilograms again in the denominator. The kilograms in the denominator will cancel out with the kilograms in the numerator, and you'll get a 1. So then your resultant units in the next line are meters squared and seconds to the -2. Now, we're not done yet. To solve for the speed, we need to square root all of this information. So we need to get the square root of 155, and we'll also square root the units. So your final answer will be 12.5 meters per second, and that is, we're being asked for speed, so we don't need to provide a direction, and that's to 3 significant figures. And this is the maximum speed. So, if the car goes any faster than 12.5 meters per second, it will then not be able to turn around the bend. Instead, it will shoot off, like on a tangent off the curve, and not be able to actually go around the bend because the force of the car entering the bend, so the driving force provided by the engine, okay, will be more than the friction force. Okay, if that's the case, then the net force will be out towards the outer, out of the circle, and you'll get a resultant vector force that's going tangential. So that's very important just to understand. Okay, alright, thanks for listening, and press like and subscribe if you want to have more videos. Thank you.